right, so yesterday we made it through all the notes we talked about all the different techniques if we get a indeterminate form. We discussed the three specific things were factoring. We talked about multiplying by a conjugate, and we looked at a problem where we rationalized a problem. If you've done a few of those, awesome. We also looked at one piecewise function. I've got two more functions I want to take a look at. So let's go ahead and let's do that after I make this do what I want it to do. There it is. Fantastic. All right, so I want to look at B and C. Question B, you have now seen this style of graph a couple of times. It was on the summer packet. I think we may have graphed it another time. We're going to look at this again one more time. Does anybody remember what this type of graph will look like? It is not a V. It would be a V if the denominator were not there. So let's do something real quick. If you're not sure, ignoring the absolute value, what do you notice about this function? It's 1. It's 1 everywhere except at... Where would it not be 1? Negative 3. Why? Yeah. If I look, I'd get negative 3 plus 3. We'd get a 0 over 0, and that's all sorts of nastiness. So we would have this. This should be a 1 if it weren't for that absolute value. So what I want to do with the limit is, of course, I want to check the limit from both directions. I want to check it from the left. And I want to check the limit from the right. Yeah. All right, so we're going to check the left limit, we're going to check a right limit, we're going to see what happens in this problem. Okay? If I check the left limit, we're at negative 3. Everyone agree with that? If I approach the limit from the left, that means we want a value that would be on the left-hand side of negative 3. So what is the value that's on the left-hand side of negative 3? Negative 4? Love it. If I substitute in a negative 4 into this function, okay, negative 4 plus 3, negative 1. If I substitute that in the numerator, what am I going to get? 1. And we've just said that this function is always going to give us 1 unless we're at negative 3, right? Which means for all of these, I'm going to not get 1, but I'm actually going to get negative 1. Except at negative 3 because, you know, negative 3 is kind of a pain. Now, if I approach the limit from the right, what's the number that's to the right of negative 3? Negative 2? Sure. Negative 2 plus 3? 1. And the top has to be positive. So this is going to give us a limit of 1. And of course, again, we've already said this is always going to give us 1 except for, like Alyssa said, at negative 3. So this is always going to be a value of 1. What do we know about this limit? That limit does not exist, but the function looks really weird. This is actually a special function called the signum function. Not that you need to know it. It doesn't come up particularly often, but it will with the limit question. They like to ask questions about this one. So there we go. Cool. That was fun. Last but certainly not least, we have C. Now C is one of the more common parametrics that we'll get. It's a function that's defined as two different functions, equations here, depending on the domain. So when actually I'm going to change the order of these. But when I look at this first line, the limit as x approaches 2 from the negative side of f of x, which of those two equations do I use? Why the first one? Yeah. If I'm approaching 2 from the left-hand side, I want the value smaller than 2. So I want to find out when x is less than 2. So this limit is going to be 2 squared minus 1, which is, sweet, that was nice. So I know that I have like 2, 3. Look, it's 3. There's 2. It's an open circle because it's not equal to. So we're going to have an open circle there. What about the limit as x approaches 2 from the right side? Which equation do we use? Second one. We're approaching 2 from the right. That means we want the values bigger than 2. So this becomes 3 times 2 minus 2, which is 4. Fantastic. So here's our 4. We have that. Now we do have to, let's answer 3 and then we'll sketch the graph. What is the limit as x approaches 2 of f of x? Does not exist. Why? Yeah, 2 different numbers. Left doesn't agree with right. They're not equal. Say whichever way you want. 2 different numbers. Cool. Let's talk about sketching this. Let's do the left side first. When x is less than the 2, we said that that goes to the 3. Let's look at this shape. What shape is this going to make? It's going to make I like that you actually incorporated the fact that it was an upward shaped one. This is an upward shape, an upward opening parabola. And this has a positive or a negative y-intercept. It says a negative, so I probably should make sure that I drag this direction. I also happen, if you are really comfortable with your parabolas, you should also recognize that this should not be shifted left or right at all. Not that you have to be that particular accurate, although it should be close. Should I continue the parabola to the right? No, because this is going to stop at x equals 2. When we get to the right of 2, we now have what shape? Line, increasing or decreasing? Increasing. And it should have a negative y-intercept, so it should be relatively steep to force that to go down below. Again, the name of the game here is being at least semi-accurate. I'm not looking for perfection, but I am looking for you to give me something, because I am not kidding. I have once asked somebody to sketch a curve, and from this set of equations, I would have got something that looked like this. At least it has a negative y-intercept. So don't, make sure that we're being careful to make something that looks somewhat like what we want. Awesome. All right, we are done with that page. Let's talk about some properties. All right, these are going to look absolutely terrifying to you in the beginning, and after we do about 3 or 4 of them, you're going to think that these are the greatest things in the world. They are so very nice. Okay, properties of limits. Limits, assuming we've got maybe a couple different limits, maybe we're dealing with one, but assuming we've got some limits in such that these limits actually equal something. I mentioned that because in 2017, up until 2017, no one really mentioned that piece where the limits are supposed to exist. And then in 2017, they asked the most ridiculous question in the world. It had the calculus teacher community up in arms going, what was that? It was bad. I have never seen so many angry math people on a message board in my life. But that's besides the point. If these 2 limits exist, otherwise we have to use a lot more logic on the problem, then we have a list of actually it should be 8 rules because we don't repeat 7 twice. But there are 8 rules that we need to know. Most of these can actually be combined into really a single concept. The basic rule is something I do want to mention real fast because some people have a hard time with this. If I say the limit as x approaches 4 of 9, what does that equal? Just trust your logic. If you had to just take a wild guess, what do you think the answer is? You're all like, this is a trick question. I think you made a wonderful guess. It's such a wonderful guess that it's absolutely correct. That is the most ugly 9 in the world. But it will equal 9. Is there an x in this problem? So it doesn't matter what the x is. A 9 is a 9 is a 9 is a 9. It stays. So that's really the basic rule with this left side, making sure that you understand constants don't change. Other than that, the sum through quotient rule can all be summed up as, instead of thinking about how this function would look if I add the f of x to the g of x and try to add functions together to create a new function, we can actually just look at the individual pieces. That's true about sums, differences, products, and quotients. I can just do the individual pieces, not think about how those interact. My personal favorite is 6. If I have the limit of a constant and a function, I can actually take that constant and pull that outside of the limit entirely because it is a constant. There's a power rule that says that I can actually take this limit and pull it inside of a power, which makes life easy. And last but not least, the composite, which is probably the strangest, that says if I have a limit of g of x going to L and a limit as x approaches c of f of x that goes to f of L, then when I take a limit, I actually take the limit of the inside piece. Then I can calculate the f. So I have to find the inner piece, just like you would with the composite function. You'd find the inside, what does that equal, and then plug that in. Same exact concept. Cool? All right, let's look at a couple of these, because that's a whole bunch of words, and let's look at the actual math. So given that the limit as x approaches c of f of x is 27, and the limit as x approaches c of g of x is 3/2, we want to evaluate these three limits. And those look gross and terrible and horrible. But watch how beautiful this is. This is a constant, isn't it? So one of the limit rules says, hey, you know what we can do with that constant? We can factor it out. Well, I know what the limit as x approaches c of g of x is. It's just 3/2. This is 5 times 3/2, better known as, and you're done. What? That wasn't bad. Obviously, I'm just trying to trick you. Lena, you look like you've got some. You don't look like you believe me that they're this nice. Let's try the other one. So if I'm looking at this, I have f over g of x. That doesn't look pretty, but what I can do is I can actually take the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. Just take that limit, split it over the individual pieces. Limit of x approaches c of f of x is 27. Whoops. Helps if I can write my fraction correct. Got ahead of myself. Yes, ma'am?
On the test, do we have to write it like that?
Fantastic question. Right now I am doing that just to show sorry, I'm on the thing. So the question that was asked is, when we go through the problems, do I have to rewrite the limits? Absolutely not. In this particular case, this is not something you're going to have to show unless it would help you. Otherwise, you're going to go through and you're going to just go ahead and jump straight to that last step. All right, I'm going to answer that. This will be great.